Greetings, fellow ampaholics. It's been like 2 or 3 weeks since my last video, and I apologize for the delay. Today's feature amp is going to be the Ward's Airline Model 62-9012A. It was made by Danelectro for Montgomery Wards to sell under their Airline brand name, which is what they call their electronic gear. It was made back around 1962 to 64, which was a real golden age for amps. I mean, I grant you this is not a Fender Vibro Verb, but it's a pretty slick little amp, and I think you'll get a kick out of it. We're going to use our normal techniques of analyzing the outside, the inside. We'll look at the schematic to see how it works. We'll compare it to some other amps from the same period, and then we'll hear it play. Okay, stay tuned. Well, externally, nothing real exciting. It's just a rectangular box. It's got the brushed aluminum dashboard here with the 2 inputs. These are equal impedance, as we'll see when we look at the schematic. Volume, tone, on-off, no pilot light, and then a panel accessible fuse holder. It's done in sort of a black Tolex material, not unlike the Fender amps. It's got the Fender style handle on top and some really nice, just mint grill cloth. Okay, this amp for its age is in just beautiful shape. As you can see, there's a little wear on the corner. All in all, pretty close to probably how it looked when it was new. Let's turn it around and take a look at the back. Well, the review is pretty basic. We got a sheet of masonite here, I guess keeping the hamsters from gnawing on the wiring. We got the original 2-wire plug, which works just fine, and I'm going to leave. We got the chassis mounted at about a 45-degree angle with the identification at the top, Montgomery Ward Model 62-9012A. We'll take a much closer look at that in just a minute when I remove it. One happy note, I don't see any white paint spots on the top. Those of you who follow my videos know this is one of my pet peeves, the idiots that set their amps out when they're going to paint the ceiling, I guess. Instead of a drop cloth, they use all their amplifiers so it can catch all the paint. One lovely vintage cigarette burn that boosts the value a bit. Okay, let's take it apart and look inside. Well, here we are with the back off, and as you can see, no real high-dollar wood was used in this cabinet. I don't see any Circassian walnut burl. Instead, we get good old masonite, and this is some sort of a synthetic board, I guess, looking at the inside of what the cabinet is mainly made of. The speaker appears to be, an 8-inch speaker, and 1056 is not a real common code. On my list it shows that that's a Fisher speaker. Now Fisher used to make a lot of hi-fi gear back in the 60s, so this may well be a Fisher speaker. It's an Alnico and not terribly remarkable. I'm a little surprised they used this bare wire to go down to it, because if these shorted, that wouldn't be good for the output transformer. We have over here the rather small and unimpressive power transformer, and we're going to see in a minute why that's perfectly fine for this amp. We've got a 6x4 rectifier. The schematic on this shows 6x5, but this one is a 6x4. There is a difference, a big difference we'll discuss in a minute. Filter capacitors, there's probably 3 values in one can. Here we've got the 6V6 output tube and the 12AX7. Now, other than this not being a 5Y3, this is really pretty much a Fender Champ circuit. Okay, like so many small amps, they relied on what was tried and true, and the Fender Champ was it. Okay, so let's take it apart and see what other differences there are. First, let's take a look at the schematic so we know what we're seeing when we look in the chassis. Both equal impedance 68K inputs. The value is the same as Fender. A lot of amps, you have a high and low impedance input. Probably for humbucker versus single coil guitars. we have the 1 meg volume right off the bat. So we're going to have our signal come in, we're going to bleed off a certain amount of it to ground depending on how loud we want the output to be. Feed into the grid of the first stage of the 12AX7. We leave the plate, come to a 0.01 coupling capacitor into the grid of the second stage of the 12AX7. Out from the plate to another 0.01, and we're going to feed into the grid of the 6V6. Single-ended 6V6, which is then going to output from the plate through around a 4 ohm Fisher, we believe, speaker, operating at around 245 volts of plate voltage. This schematic shows a 6x5 full wave rectifier. This particular amp has a 6x4. The two tubes are completely different externally, but internally they're the same. So this works. Other than the pin numbers, this is the way the rectifier is set up. Down here, the filter capacitors, we've got a 5, a 10, and a 10. This would be an ideal chassis, I think, if somebody wanted to build an amp from scratch and just wanted to start off kind of at level 1 with difficulty. This is just a really nice, simple, nicely configured little chassis, and it really works well. Next, we're going to take a look at the rectifier tube of this versus what we normally see in amps like this, which would be a 5Y3 rectifier. Other than that, this is just like the Champ circuit. Anytime I see a change in what is the standard configuration on 3-tube amplifiers, normally you have a 5Y3 rectifier. Why would they change? And it's almost always to save money. Let's take a look at the 5Y3 compared to the 6X4 that is in this chassis. First off, filament voltage, of course, 5 volts for the 5Y3, 6.3 volts for the 6X4. Right off the bat, here's an advantage. You do not need a special winding in the power transformer of this amp for the rectifier. We can use a regular filament style transformer that has 6.3 volts, and it works with the rectifier also. Heater current. Most rectifiers in the older amps are just current hogs. The 5Y3 draws 2 amps, whereas the 6X4 only draws 600 milliamps or 0.6 amps. So it's less than 1/3 the current draw, which is going to allow us to use a smaller, less expensive transformer. DC output current, 5Y3, of course, is going to beat the 6X4. It's 125 milliamps versus 70 milliamps. So we get over half the output with less than 1/3 the input. And I've come up with a real crude efficiency calculation here, output versus input. 5Y3, 6.25%. 6X4, 11.7%. So I'm sure the 6X4 was a cheaper tube. We can do away with one of our windings on the power transformer, making it less expensive. We can do away with a whole bunch of heater current, which allows us to use a smaller and, again, less expensive power transformer. So it really does all make sense. Now, with the 6X4, you're not going to, because you're down here, you have 70 milliamps versus 125. There's a thing called sag with these amps, and I have a feeling this is a saggy amp because it's going to take this transformer a little more time to catch up with demands. When you hit a chord at high volume, there's going to be a little lag between the demand and the supply of current. Okay, sag to many people is a good thing. So that may be considered actually a benefit of this design. Before I continue, there's one point I wanted to touch on, and that is when you're buying these little small 3-tube amplifiers, it's something you really need to watch out for. Now, this particular one has a power transformer, and if you notice, the primary, in other words, from the wall plug, comes in here and only goes through the primary of the transformer. In effect, this is an isolation transformer as well as a power transformer. Now let's compare that to this schematic, which is for a 3-tube. There's 12AX7, 50L6, and a 35Z5 3-tube amp. This is a magnetone, but there is a huge difference between them. and that is this amp does not have a power transformer, and you're going to encounter these from time to time. When you're going to buy one of these amps, don't just look in and count the tubes and say, oh, 3 tubes, it's fine. Some of them only have 2 tubes, and for a rectifier, they'll use a diode down here. They're really getting scrimey on tube use. But there is an issue here. If you don't have a power transformer, and this one doesn't, what it does is it feeds in the 117 volts, and the filaments of the tubes, notice this is 35, 50, and 12AX7, and other losses in the circuit add up to around 117 volts. So there is a voltage drop due to the tubes, which is equivalent to the voltage input, so you don't really have to have a step up or step down transformer. The tubes dissipate the voltage. So in this case, with no power transformer, you run a problem, because depending on how you plug in the 2-prong plug, in some cases your chassis is going to be 117 volts. If the black wire from your wall wiring is connected to this wire here, you've got a 117 volt chassis, which would be very uncomfortable if you're barefooted on a cement floor and you reached around back and touched it. It wouldn't be healthy. So people have to add isolation transformers, and on the internet there are schematics how to do this, to protect themselves. In other words, they add a transformer that really makes it more like the schematic that we just saw, the little Airline amp, that has its own built-in isolation transformer in the form of a power transformer. So if you're going to buy one of these, check the tubes. If you see 50L6 or 35Z5, that may be just fine for you. That may be a wonderful amp for you. But bear in mind that you really ought to add an isolation transformer to make it safe, and that's not cheap. It's going to cost you another probably $25 or $30. So please consider that. All 3-tube amps are not created equal. Okay, now let's get back to the little Ward's Airline. Well, there were 5 screws holding the chassis in, and now it's out. And as you can see, it's in immaculate condition and just as simple and basic as it can be. I would say this would be a great design for someone who wanted to fabricate their own amp from scratch. You can't get much simpler than this. Okay, here's the cathode biasing resistor for the 6V6. The various completely sealed capacitors. They're not the old waxy type that are prone to leakage. I'm going to use the ESR meter to test the filter capacitors, but due to the lack of any hum at all in this amp, I have a feeling they're in just fine shape. So there it is. I guess PS may be the initials of the person who hand-wired this back in 62 to 64 at the Danelectro factory. I hope he's watching. So that's it. Okay, it gets no more basic. Go get a sheet of thin aluminum, get some drills and hole punches, and some capacitors and tube bases, and start fabricating your first amplifier if you haven't already. Okay, let's put it all together and see how it sounds. Okay, we're all plugged in here. We've got the volume and tone straight up in fairly neutral positions. Let's see how it sounds. Well, let's see how many negative adjectives we can come up with. Weak, lousy bass response, kind of tinny. It has a kind of a sound like it's echoing in a box, which it really is, I guess. I lay 90% of that on the speaker, to be honest with you. Fisher might have made good hi-fis, but they made lousy guitar speakers. Let's try this with a decent speaker. Okay, now we're hooked up to my shop test speaker, which is no great shakes, but it's a whole lot better than the 8-inch Fisher, I have a feeling. Let's see how it sounds. I'm not sure how it's going to come across on YouTube, but here the difference is huge. Okay, all sorts of bass and mid-range that we're missing. I think it proves the point that the real limiting factor in these small, inexpensive amps are the rotten speakers they put in them. This particular amp would certainly benefit from a nice, like an 8-inch Jensen speaker, decent quality speaker like Fender Champs had. And I really think that for the money, all the tone and sound is in there. It's just a matter of hooking them up to a speaker that can portray it. Well, there's nothing I like better than taking things to ridiculous extremes. So here I plugged the little Airline amp into a 3x15 custom speaker cabinet. So let's see how that sounds. Well, that about does it for the mighty Ward's Airline 62-9012A made by Danelectro amp. We had a lot of digressions and added information with the transformerless amps and the 6x4, 6x5 rectifier. I hope it was interesting. I hope you liked it enough that you'll join me in the future for more videos, or maybe even subscribe if you haven't already. Either way, I really appreciate your time and your interest. I hope to see you again in the near future. Bye for now.